Let's look at histograms and bar plots or bar graphs or something like that. What's the difference? Well, histograms, they should go with continuous data. Now again, this is where your textbook is a little off, I think. Continuous numerical data, and then bar graphs, they should go with discrete and categorical. Now, what's the difference? The only difference is that in histograms, when you talk about the histograms that are in the text, when you think of a histogram, you should think of all these rectangles or bars, and they should be touching each other, unless there's just data missing. But the idea is that when you look at it, you should have bars touching each other, and then a bar graph or bar plot or bar chart that would also have these bars, rectangular bars, but they don't usually touch each other. Now, people get sloppy. Sometimes software doesn't do that great a job at making these things and so forth. So, yeah, it's certainly possible that you really should have a bar plot or bar graph, but it ends up looking like a histogram because the bars are touching. Really, you should never have a histogram that you end up drawing as bars, individual bars, because a histogram does talk about a continuum. So now what are we doing? Each bar. Okay, so what we want to do is simply look at some sort of variable and its different levels or values. So a variable, and I'll just call it x as some variable, and that's what we'll think of as a random variable usually, and it will have different levels. So x, it could be, let's take something like, just I roll a die. Now this is something discrete. If I roll a die, usual die, I could get a 1, 2, 3, 4, 5, or 6, and then count from my experiments. If I do that, then it could be I rolled this thing a total of maybe 30 times or something. I rolled a die and I counted how many times I got a 1, and maybe there were 2 times I got a 1, and 7 times I got a 2, and 5 times I got a 3, and 5 times I got a 4, and what am I up to? That's 10, 19, so I have 11 more, and so maybe I had 6 5s and 5 6s. And so I could have that count, and then what I would typically do is to, so I've represented this tabularly, but I would like to represent it graphically. And so what we do is you could think of it as kind of like just x's and y's in some ways here, because I've got my 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And now with the counts, that's going to be the y variable. So 1, 2, 3, 4, 5, 6, 7 up to there. So 7, 6, 5, 4, 3, 2, 1. And I had 2 1s. I was a little off there. 7 2s. And then 5 3s, 5 4s, 6 5s, and 5 6s. So you see, I could just plot the data like that. Now, what we tend to think of, though, is with these counts, and if we're talking a bar chart or bar graph, we could think of it as sort of piling up stuff, and and maybe I had a bunch of blocks and I piled them up, and oops, it really should be about there, so if I would have 2 blocks that I piled there, and here I would have these 7 blocks. But notice now I've got stuff tight together here, but notice because these variables can only take on 1, 2, 3, 4, 5, or 6, that's why I separated them like I did up here. I separate them and give a little space in between there. But you see, all I've done by using the bars is that it makes it very, very simple for me to look at the relative heights. And I think it's a little easier for me to see the heights this way than if I just had the dots. Okay? But you could just use the dots and call it a scatter plot of the variable here and the count. In that case, I'd call it a scatter plot. But by making the bars, I think it's visually, I can see the relative heights better. And then on top of that, I can also intuitively think of it as, yeah, every time I got a 1 or a 2 or a 3 or whatever, I just stacked up a die that got that value up like that. So 1, 2, 3, 4, 5. I could think of it as stacking up those dies that came up as those numbers. And so I think there's some intuition there, or something that makes that somewhat natural. So, this is the way we would tend to do a bar chart. And now, I could have had these touching each other, but the point is, by using the bars, I can see that they're, it's telling me by using these separated bars, there aren't values like 1.5 and 2.5 and 2 1/4 and 4.389 and things like that. There are no values that are coming up like that. There are just these counts of 1, 2, 3, 4, 5, 6. Okay, so that's all I'm doing by making one of these bar charts, or what we'll see is also a histogram, same idea. But that's it. We're just making them that way. Now, for a histogram though, the difference is that when I get my x's, I might have something like this where all my counts, so here's count, so maybe I measured the length of some leaves on trees or something like that, and I got 2.2, 2.4, 2.5, 2.8, 2.9, 3.1. Now, and just for my convenience, I'm putting them in some kind of order here. Then, 3.2, 3. I'll do another 3.2, 3.3, 3.5, 3.6, 3.6, 3.6. I don't know how many numbers I have here. 1, 2, 3, 4, 5, 6, down to the 3.1. 7, 8, 9, 10, 11, 12, 13. I'll do a couple more. 3.7, 3.8. Now, if I were to do a count here, most of these would just have a count of 1. And, that wouldn't do much good. And so, probably when I have these continuous numbers that could be anything now, and I put 2.2, well, it could have been 2.28476, if you want to say, well, it only goes to the first decimal. Well, actually, no. If I can always measure to many, many decimal places. It's just how good a measuring device I have. Now, so I look at this, I would get a bunch of 1s on the counts here. And so what I might want to do is, and typically with a histogram, you usually would use all the same size bins. And so notice I have numbers that go from 2.2 to 3.8. And so what I might do is I might say, okay, I'm going to take all the numbers from 2.5 down to 2. Now there is no 2, but I'm taking all those numbers. And then from 3 down to 2.5, but bigger than 2.5. And then from 3.5 down there, and then from 4. And so I go every 0.5. So this is my 2 to 2.5 block. And I'm going to do this. I'm going to say 2 less than or equal to 2.5. And, well, yeah, it doesn't make sense. So I won't do that. But anyway, so I'm including the 2.5 in this block. And I'm including the 3 in this block here. So this line is at 2.5, 3.0, 3.5. And so if I looked at this count, I'd have 3 things there, 2 things there, 1, 2, 3, 4, 5 things there, and I think 5 things here. And so now this, whoops, look at that, this, I would build a histogram. And so here might be 2, 2.5, 3.0, 3.5, and 4.0. And again, I would do that count. I'd go up here, 1, 2, 3, like that, and then just 2 of them there. So I would have block that tall and that tall. I probably made that too tall. So we'll kind of mess up our scale here a little bit, but these are both 5s. So there were 3 here, 2 there, 5 there, and 5 there. And now they touch because you see this is saying, well, I've got all possible values between 2 and 2.5. I've got all these possible values between 2.5 and 3. All these possible values between 3 and 3.5, and then 3.5 and 4. But how many did I actually observe? Oh, I actually observed 3, 2, 5, and 5. And so that's how I'm using a histogram. And so that's how a histogram is different than a bar chart, is that when I see a histogram, I'm assuming, well, did I get a 3? Or did I get a 3.5? Or well, I don't know. I might have gotten a 3.1. I might have gotten a 3.28647. I'm not sure. I got some number in between here. Whereas when I see the when I see the bars like this that are separated by space, I'm saying, oh, I got a 1, I got a 2, I got a 3. Whereas here, when they're touching each other, I think I could have gotten anything in there between the lowest side and the highest side. And you have to be a little careful about the quality part. Here the 2.5 was in the left-hand side. The 2.5 was included there, the 3 was included there, the 3.5 was included there, and so forth. Because notice, if I took those same numbers, 2.2, 2.4, but said at 2.5, I draw the line and I go to the right, then this would be 2.5, 2.8, 2.9. Still have a line there, 3.1, 3.2, 3.2, 3.3, line 3.5, 3.6, 3 of those, 3.6, 3.6, 3.7, and 3.8. Oops, 3.8. And so now on my counts, you see I only have 2 there. I've got 3 there. just 4 there, and then 6 here. So even though it's relatively similar, you see my choice of where I put those lines and make those divisions can, you know, so there's 2, 2.5, 3, 3.5, and 4. Now all of a sudden, you see this is a 2, that's a little taller at a 3, a little taller at a 4, and then all of a sudden really big here at a 6. And so that looks a little different than that one did, yet it's exactly the same data. So it's not way different. Again, here on this, I can see the left side is smaller than the right side. The left 2 are smaller than the right 2. I can see that again here, but I get a nice stair step on this one that just keeps trending up, whereas this one kind of came down, went back up, and leveled off. But yet it's exactly the same data. So if you don't have a lot of data in particular, then where you end up drawing those lines can make a bit of a difference in the picture. Not a huge difference, but somewhat. And then, if you have a lot of data, usually drawing that line and saying, oh, we'll include to the left or we'll include to the right or something like that, it may not make so much difference. That's where lots of data can be very helpful. But you see, that's a big difference between bar charts and histograms. Is bar charts, pretty much I probably have a single bar for each value, usually. And then if I go with clumping data, even if it's, in that case, discrete data, then I probably want to use a histogram to show that more than one value is possible within here. And so, for instance, your textbook has discrete data, but it lumps it together into bins. We call these pieces here bins. And as soon as you lump it together into those bins, probably a histogram is just fine, even though you might not be able to get all values. Probably what I would do is if I had discrete data in bins, say it was going from 0 to 5, and then the next numbers were 6 to 10 or something like that, I would probably draw my stuff like this. Here's 0, 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10. I probably would try, if my software allowed it and so forth, if I collected all numbers from 0 to 5 like this, but then the other numbers were 6 to 10, I would probably try to put that gap right in there and make a bar chart that looked like this. Because then it makes it very clear, I know I'm working with discrete data, and I know that the 6 through the 10 go together, and maybe the 0 through the 5 go together. If I put them together, if I've got, here's 5, here's 6, there's 4, and so forth. If I say, well, okay, I'm going to put that line right there at 5, well, did the 5 get counted with this group, or did the 5 get counted with that group? I don't know. And that's where that gap might be a little better. Another way to handle that would be to make a histogram. There's 5, there's 6. You can't get a 5.5, but you put your histogram this way to show that the 5 did indeed go over here and the 6 went there, if that's what you're doing. But see here, I have a question. I don't know where that 5 was actually counted. And so that's a problem. Okay? So when I lump data together in bins, I can use a histogram because in a way, all I've done here is I've taken a bunch of these rectangles, fused those together and left one out there. I mean, you could think of that's what I really did, but it's one big rectangle like that, one big rectangle like this. But I'm just trying to show the reader what I did. So what's the right thing to do? Well, the right thing to do is try to show the reader what you did. And this is one way to do it right here by putting that gap. This one is another way by putting the line at the 5.5. This is a bad way. I don't like that way because I can't tell where the 5 went. So the big thing is when you represent data and so forth, just try to make sure people know what you're looking at. So that's at least one video on this idea of histograms and bar charts and what's going on. All we're doing is looking at the counts and making plots that tell me how many count, what's the count of each of these items here. And again, the histogram can have many values represented within that bar. A bar chart really should only have one value represented. Okay, and that's long enough for that video. That's a pretty long one, and so we'll do some more work with it in some other videos.